Welcome back to Tech Pulse, your go-to show where we break down the latest breakthroughs in science and technology, making them not just digestible, but actually exciting. I'm Zaper.
And I'm Puck. Think of me as your front row seat to curiosity. I ask the sharp questions, challenge the details, and make sure you don't have to. Quick reminder, hit that subscribe button, drop a like, and share this with a friend who geeks out about space as much as we do.
Today, we've got a headline that's literally out of this world. Astronomers have captured the first image of two black holes orbiting each other, confirming decades of theories and solving a 40-year-old cosmic mystery.
Deep dive into discovery.
That's right. This isn't just any black hole snapshot. We're talking about two supermassive black holes locked in a 12-year orbit at the center of quasar OJ287, located 5 billion light-years away. The research was published in the Astrophysical Journal just a few days ago, October 9, 2025.
The team, led by Mauri Valtonen at the University of Turku in Finland, used cutting-edge radio telescope technology to distinguish the two black holes. Remember, in optical light, they look like a single point, but thanks to radio waves, we can now separate them.
And the scale is mind-boggling. The larger black hole is 18 billion times the mass of our sun, while its smaller companion is still a whopping 150 million solar masses. The binary nature of this system was hinted at back in 1982 by Aimo C. Lanpa, who noticed periodic brightness variations.
Here's the kicker. The imaging required resolution 100,000 times higher than what optical telescopes can achieve. They pulled this off with RadioAstron, a satellite that extended an antenna halfway to the moon, combined with 27 ground-based observatories worldwide. That's effectively a telescope 5 times the diameter of Earth.
And there's a twist, literally. The smaller black hole produces a twisted jet, what researchers are calling the wagging tail phenomenon. It's like a rotating garden hose, twisting dynamically as it orbits its massive companion. This gives us clues about how gravitational waves might form when these giants eventually merge, waves detectable by observatories like LIGO.
To summarize, for the first time, we have visual confirmation of a black hole pair, insight into new jet behavior, and the technology to peer deeper into the universe than ever before. Einstein and Hawking, eat your heart out.
Opinionated segment. Heated discussion. All right, Puck, here's where I go full opinionated mode. I think this discovery proves we're finally scratching the surface of the universe's real architecture. Black holes aren't just isolated monsters. They interact, dance, and literally shape space-time. And honestly, I think we've been underestimating how much binary systems drive cosmic evolution.
Zaper, I see your point, but I've got to push back. While this is incredible, let's not romanticize it too much. Imaging two black holes is one thing, but our understanding of their actual dynamics is still rudimentary. The wagging tail jet? Sure, it's cool, but calling it a cosmic revolution is a stretch. We need years of data to fully grasp its significance.
Respectfully, Puck, I think you're being too cautious. Every breakthrough starts with a single image or observation. This is literally confirming 40 years of theoretical predictions. Einstein, Hawking, you name it. It's the rare case where theory and observation finally shake hands.
True, but let's not ignore the tech limits. The RadioAstron satellite retired in 2019. We're still relying on piecing together past data, not live monitoring. So while the resolution is impressive, the universe is dynamic, and our snapshot is still a fraction of the story.
All right, fair. But if you ask me, this is a proof of concept for the future of high-res space observation. It's a glimpse at what comes next: smarter, larger, space-spanning instruments.
Agreed, and that's what makes it exciting. We're in the era where theory meets tech, and even a single image can rewrite textbooks. But let's temper hype with rigor. Enthusiasm, yes. Exaggeration, no.
Outro. So, to wrap this up, Einstein's equations still holding strong. Hawking's theorems confirmed. And thanks to advanced technology, we're peeking deeper into the universe than ever before.
And that's just the beginning. We'll keep bringing you these cosmic updates, clear, bold, and just enough jargon to keep it fun.
That's all for today's episode of Tech Pulse. If you enjoyed this, hit like, drop a comment, and of course, subscribe so you never miss a moment of the future.
I'm Puck.
And I'm Zaper. Thanks for tuning in. See you next time on Tech Pulse.